I think more people are going to join in along the way, but I'm going to start. So hello, NL people. Thank you for joining. I wanted to have a few words before I introduce our guest. On the 16th of February, we're going to have our third live event at the Macromedia University of Applied Sciences in Munich. The event will also be streamed and recorded. And yes, after that, we have talks about like this every week, ranging from machine learning or linguistics. We will have talk about some exciting open source projects. And as always, everything will be announced on our Discord server, which is linked in the description if you're watching this on YouTube. And now about Darek Kłeczek. He is currently responsible for the education program at Weights and Biases. He used to be involved in the machine learning automation at Procter & Gamble. He's a Kaggle competition master, and he also is the contributor for the Polish versions of GPT and BERT. You can go to his GitHub page and leave him a star and show some love. And yes, today we're going to talk about machine learning and training models. So thank you so much for joining us. And yes, let's start.
Thanks a lot for the invitation. Appreciate being here with you. Let me share my screen. Share this one. Okay, hopefully you can see my my screen now. So thanks again for the invitation. My name is Darek, and I want to share some tips and tricks on how to train better and faster NLP models. Before I go to the presentation, some more background about me. I got into machine learning and NLP around 5 to 6 years ago. And the reason I remember this exactly is this was when my daughter was born and I went on a paternity leave. I spent time with her when she was awake, and when she was sleeping, it was still the time when she slept quite a lot. I would study machine learning. And I thought it was a good idea to come up with some motivating project that would that I would want to do and learn machine learning and improve my skills on. And that motivating project was generating nursery rhymes in Polish. Yeah, I like that was before ChatGPT. I feel like this problem has been solved now, but at that point it was still quite difficult. I got it to work with an n-gram language model, so it worked reasonably, not as good as you can get it done from ChatGPT today, but still it was a fun project that got me interested in machine learning. And since that time, yeah, I did manage to get the first published Polish BERT language model out there. I also engaged in machine learning. I was working in Procter & Gamble at that time, and I was able to also apply NLP in a real business context. I work on topic models that help us better understand what employees are doing and what tasks might benefit from automation. I worked on aspect-based sentiment modeling, and we were looking at consumer comments and trying to understand what consumers think about P&G products, and especially in a more granular way. Do they feel like the price of Pampers is good or is too expensive, or whether they think that the performance is good or bad? And trying to distinguish this was an interesting problem to try solving. I also got into machine learning competitions, and all of that led me to Weights and Biases, where I have this fun role of being a growth machine learning engineer and getting to engage with the community, getting to work on interesting problems. Most recently, I've been exploring protein language models, which is close and far in terms of NLP at the same time. And I've been also looking at information retrieval. So with this background, yeah, let me actually check chat. Yeah, if there are any questions, by the way, feel free to put them in the chat or unmute yourself and ask them as we go through the slides. I appreciate having an engaged conversation throughout this session. I always feel this is more engaging if we can interact while chatting through this content. So the agenda, I'll start with some perspective on NLP use cases. By the way, this whole session is going to be very subjective. Like, that's my experience and my own research. It's something that you should validate for yourself, but hopefully these tips will hold when you check them out. So NLP use cases, data. We know data is quite important for training machine learning models. I'll give you some perspective on that. How to choose a good architecture and a set of hyperparameters. Couple of things about regularization, which I found is super important, especially with deep learning models like transformers. Debugging and good engineering practices. That's something that I feel like really I upped my game here in weights and biases in this aspect. And if you stick around to the end, you may I will share with you how we can win some weights and biases swag. So hopefully you stick around, you find this session useful, and you keep asking questions and engaging throughout. So the NLP use cases. I recently had a conversation with some fellow machine learning engineers, and it was in the context of the recent hype around large language models. I feel a lot of this hype was brought by ChatGPT, which I personally find super useful and helpful. And the question was like, okay, so what happens with, you know, the type of models that we've been using for the last couple of years? Like we've used large language models like BERT, Roberta, the Berta, and I feel like they still have a place. And the way I for myself, like I found like a way to distinguish like where do models like ChatGPT fit and where do models like BERT or Roberta fit is this distinction between generative and discriminative use cases. So generative use cases is, you know, typically working with prompts and getting some sampled output. It can be used in generative question answering, copywriting, maybe creating automated product descriptions, composing novel protein sequences. You know, whenever we don't have a good expectation of what to get out, but we're trying to, we often want to be surprised by the output in a good way. I feel like this is where the models like ChatGPT actually work quite well. The implications of that is these models are also very hard to evaluate because the evaluation here is subjective, or very often bigger models work much better. And it's important to figure out like how to sample from a distribution here. So sampling techniques like nucleus sampling and so on are quite important. On the other hand, we have the discriminative use cases, and this is like let's say the classic machine learning class, such as sentiment classification, maybe named entity recognition, detecting spans, the traditional extractive question answering. And this is still what I feel the majority of current use cases are in the industries, and it's important to also be able to solve this type of use cases with NLP. And my presentation will be more focused on this part. I think this is something that still benefits a lot from training good models, and we can do it on a reasonable GPU in a reasonable amount of time. The implications here, these models are easier to evaluate. We're typically dealing with supervised data sets. Smaller models often work quite well. And here sampling is maybe not so much relevant, but it's important to formulate the problem in a good way. Let me check if there are any questions in the chat. I think we're good. So continuing with the use cases, I listed here a couple of recent NLP competitions on Kaggle. And there was a time a couple of years ago on Kaggle where there were almost no NLP competitions. It was all computer vision, maybe some tabular data competitions, but no NLP. But in recent year or two, like there's been this explosion of NLP use cases. And I feel this is evidence of the fact that NLP really is quite has a very broad reach right now. There are a lot of problems we can solve reasonably well with NLP models. These use cases, by the way, they vary across industries. There are problems that come from education industry. There are things around developer tools. Some of you may enjoy GitHub Copilot, and I feel like there's still a lot of potential there. Legal, medical, trust and safety use cases, search. I feel there's a range of problems that we can solve with NLP, and these also problems sometimes have very interesting framings. It's not all sequence or text classification. Sometimes we need to extract and classify spans. Sometimes it's about predicting order of different sequences. There are question answering formulations and so on. So I feel having good skills on how to solve this type of problems, how to formulate them is very helpful, and can be used in the industry to generate a lot of business value. So how do we train these models in a better and faster way? And here the first point is obviously data and data sets. And in an ideal scenario, we have a lot of high quality data, and high quality means like we have good labels that have been developed by subject matter experts. There is little noise in the data, and we can train a good model with that data set alone. I see a question from Piotr. Is there any model of question answering in Polish? Generative techniques. Yeah, I think the problem in Polish is we don't have a good question answering data set. Like we don't have a Polish version of Squad. So I think what I've seen, and I haven't caught up recently, but I feel the problem is we don't have a good question answering data set. What we can do is we can train a Polish model or like a multilingual model on English and then use it on Polish language, but that will not work very well. We can use like ChatGPT, which also knows some Polish, but then we need to experiment with prompting and maybe combining that with information retrieval and putting similar like the retrieved documents into the prompt. So yeah, I feel like there is a lot of opportunity to work on question answering in Polish. Since this is Munich NLP, I think like actually you're one step ahead in Germany. So there is German, but I think there are German question answering models. I think Haystack developed a German version of Squad. So for German, this is a bit like a bit step ahead. Good. Going back to data. Yeah, so what happens if we don't have this big high quality data set to train our model? I feel like the minimum requirement that we need to have is having a high quality validation data set. So when I work on machine learning problems, like very often we would not have any data, and the first step was creating a validation data set. And I would often do this manually, like manually label a bunch of examples and use this as a validation data set. I think training can be more noisy as long as we can evaluate it properly. But then, like, what do we do about training data? And here there are a couple of things that we can do. Ideally, we have some high quality data in training as well, but the more data, the better. So how do we extend this? And I assume that we might have access to some unlabeled data. Like typically unlabeled data is easier to find. We can use this unlabeled data, for example, with in-domain pre-training. Most of the models that we use for NLP have been pre-trained on large data sets like Common Crawl or Wikipedia and so on. But we often train models on very specific niche domains. Maybe we are focused on some e-commerce examples. Maybe we are focused on some medical texts. So these are typically different from whatever our model was trained on in the pre-training phase. And continuing with the pre-training on our domain data is often helpful. That's something that's worth experimenting with. And this means like taking an unlabeled data set, taking a language modeling head, putting this on top of the backbone and doing like masked language modeling task on our unlabeled data. So that's one thing we can do. The second thing is searching for labeled data sets from similar tasks. And here I'll give this maybe academic example. So there are different question answering data sets in English. One of them is called Squad and is relatively easy. Another is called natural questions and is much harder. And if you want to train a good model on natural questions, it's often beneficial, like it is actually beneficial to first train your model on Squad, which is easy, and then take that model and continue training it on natural questions. And this applies also to whatever custom, like specific problem you're working with. So what I would often do when I start working on a new problem is I'm trying to think or search for similar problems and similar data sets that exist, and potentially in different languages as well, and try to train a model on that different data set first, and then fine tune it on my data, and that often helps. A question from Charlie: what is MLM RTD? These are the approaches to pre-train language models. So most of the solutions to NLP today are based off transformers, and transformers are pre-trained in a self-supervised way, which means like we have a large corpus of text, of documents, and we create examples there by either masking some tokens, and this is masked language modeling, MLM, or by replacing tokens and changing order, and this is RTD, replace token detection. These are techniques to pre-train models on unlabeled data. So pre-training, adding data sets from adjacent or similar tasks. Going back to this example of training a Polish question answering model, we have almost no Polish data sets for this. We might create a small one ourselves, and then maybe use English question answering or German question answering data sets to train our model, and that should help also for Polish. And that's the case also for whatever problem you're working with. Trying to find an adjacent data set may be helpful for your model. And the final technique here is pseudo-labeling. And the way to do this is we train a model first on the data that we have available, the label data that we have available. This may be a small data set. We can actually invest quite a bit of time in training, trying to train a good model on this small data. And maybe we can use a big model for that. Maybe we can use an ensemble of models. And then we take this model that we've trained and we label a bunch of unlabeled examples with this model. Let's say we are trying to train a named entity recognition and recognize names of let's say we want to take a named entity recognition model and train and recognize personally and identifiable information in our documents. And we have a small data set of PII, of this personally identified information. And we can train a model on our small data set and then take a bunch of documents and try to label those documents with our model. And that will give us a set of noisy labels. Like we'll have documents, we'll have the things that our model recognized as PII. And the problem with it is it's noisy, like there will be errors there. But practically what happens is training our model with this noisy data will often improve its performance. And that's something that I would also recommend experimenting with. So using pseudo labels is a good way of adding data to our model. Even if it's noisy, it can still be helpful. And then the last point here is at the very end, I would always recommend to fine tune on whatever high quality data we have. And this is like the final phase of calibration. So we can have a lot of noisy data and then some high quality data. We first train a model on all of the noise, and hopefully it will learn some general patterns. And at the very end of the training, add this high quality data that we have. And here, like the model will already have a good understanding of patterns, and you can then calibrate it and make it actually work pretty well with little amount of data. So this is a set of tips that is related to data. Let me pause here, check if there are any questions before we continue. Okay, so let's move forward. So how do we choose, so once we have the data, how do we choose a good architecture and hyperparameters for our model? So what I do usually is first picking an architecture. I would often look at different benchmarks that are available, try to find a task that is similar to whatever task I'm trying to solve, and see what models work well on those benchmarks. And papers with code is a good source of these benchmarks. I often find Kaggle competitions is actually a great source because it's much more realistic than some academic papers. Like typically the benchmarks are maybe hard to reproduce on Kaggle. Like we can often get solution descriptions with code that verified some of the techniques, and I feel like they are battle tested if they work on Kaggle. We can also look at the recent papers and repos and see whatever is available for the task that we're solving. And then an important choice is then for each of the architectures that we want to test is how to choose hyperparameters, like what learning rate should I pick, what batch size, what optimizer, and so on. And here my approach is like I would usually start with checking the paper for a given architecture. Let's say I'm trying to train a BERT model. I would check the BERT paper and see what the authors of that paper used for fine-tuning. And if they list these hyperparameters on the paper, like that's usually a very good starting point. If that is not available, I would often start with some defaults. Like typically, if you're using libraries like Spacy or transformers, there is a set of defaults that is a reasonable starting point for majority of models. And I would also try to browse Kaggle and see whatever worked for people, maybe it will work for me as well. And then once you have this set of, let's say, this grid of architectures and hyperparameters, then comes evaluation and testing. And I'm gonna share with you an example of evaluation I recently did, and this is an information retrieval use case. And that is coming from a recent Kaggle competition of information retrieval. And here I'm trying to maximize recall of our model. I'm searching for a set of documents in a broad corpus of documents, and I want to make sure that within like the top 100 retrieved documents, like there's a maximum recall of the documents that are my target labels. And then I took a set of hyperparameters here that my parameter is actually the way that I formulate the input into my model, like which elements of a description of a topic or content item I pick. And then I tested a bunch of these different parameters. I actually used a sweep from weights and biases here. And then based on this sweep, this hyperparameter search, I can pick like whatever works best. So if I filter here for this best set of choices, like in this case, like actually what I found is like going with the minimal set of information works the best, which means like I don't add any additional information here. Now, after doing this initial sweep, testing some of the problem, let's put it like testing different ways of formulating the problem, I then took a bunch of backbones from sentence transformers and then evaluated each of these backbones. The result here was actually quite surprising because we're dealing with a multilingual data set, but a model that was trained on English actually performed the best. So you can see the results here. The mini LM sentence transformers, actually a quite small model, had the best recall across like these different models, even though some of them are multilingual, and this one is supposed to be in English, but it works well somehow mysteriously on this multilingual data set. So going back to the slides, check out, I always recommend check out top Kaggle solutions, check out papers with code benchmarks, pick the right set of hyperparameters from the papers, and evaluate them ideally in an automated way. So here I was able to run the sweep like overnight, and I got the results. And actually, I'm still working with the backbone that and the set of configurations that work well in that sweep. Let me pause here. Thanks for sharing the link to the BERTA paper. Actually, I do have a slide on this. So I mentioned the BERTA, and this is not accidental. Like what I found is over the course of the last year or so, there's been a bunch of competitions on Kaggle, and it seems like the BERTA is winning all of those competitions. Maybe one limitation here, it's an English model. So there might be a multilingual version, but I think for all of those competitions were in English, and the BERTA proved to be the best backbone. In the past, people would often ensemble a set of diverse backbone architectures. Recently, it seems like everyone is just using the BERTA, and it just works very well. If you're interested in the details, the paper is actually quite insightful. They add some I think quite smart modifications on top of like a standard BERT, but somehow they managed to train a backbone that works very well across a wide range of problems. So right now, whenever I start working on a new English language problem, I would usually start with the BERTA. It seems like this is potentially the best choice right now, unless we're talking about generative language modeling and ChatGPT and so on. Okay, so moving forward, so we've picked our architecture, we've picked our set of hyperparameters. So what do we do next? Obviously, we train our model, and what I'm showing on the right is a snapshot from this loss landscape gallery. This is something I find very fascinating about deep learning, like how the deep learning training is searching across this hyperparameter space to try to find a good place on the loss landscape. And what we are trying to do with our training is we're trying to find a spot on this landscape that is very low, so it has low loss, and at the same time, ideally, it should be also quite wide. And the reason we want a wide spot on this loss landscape is because we want our model to generalize well to examples that may be different from what we see in training. So training a model that can generalize well, that can perform well in production on the test set, like that requires finding this low wide minima on the surface of our loss landscape. And to do this, like regularization helps, like the classic regularization with weight decay is obviously quite important. But then the additional things you can do is you can explore augmentations and adversarial techniques. So let me first start with augmentations. Augmentations for NLP has been quite controversial for a long time. Like people try to do things like replacing words with synonyms, and so on. And these traditional NLP augmentations historically have not worked very well. But what I've seen recently, and I've also experienced myself, is that some of the augmentation techniques that come from computer vision seem to work very well on text as well. And specifically, the things that you might have seen in computer vision is random cropping, which is like you take just a part of the picture for your training, and you can do the same in text with randomly cropping your text and just taking a piece of that text for training, for classification, for example. And that's one augmentation you can do. We have this technique called cutout in computer vision, and the way to apply this to text is to randomly mask some tokens, and that seems like a lot of people use this, and it's very popular augmentation technique for NLP. And finally, in computer vision, you can also do this progressive resizing, where you start training on small resolution and then you gradually increase it over time. And you can do also this thing in text, start with short sequences and then gradually add up to a bigger sequence length. I think this actually, like this was even used in the original BERT implementation. Like the model, I think, was trained first on for a very long time on a sequence length of 128 tokens, and at the very end was trained on 512 tokens. So I feel like this progressive resizing is also something that can help you train a good model faster. We pause, see if there are any questions coming. Okay, so the other thing that I found recently quite helpful for regularization is this adversarial techniques. And these techniques come from these adversarial examples. So you might have seen how in machine learning you can add some noise to an input example, which could be an image, it could be a text, and then by adding some noise, you can actually drastically change the prediction of a model. That noise is not random. That noise is going actually in the opposite direction of the gradient, I believe. So it goes in the direction of changing the prediction from the model. So this is something that people found quite scary about using machine learning, because the models can be fooled by adding some noise which is invisible to people, but can be picked up by machine learning model and change the way it makes its predictions. And from that standpoint, there's been quite a big amount of research in a way of defending against these adversarial examples. And there's been a bunch of techniques that people experimented with. And the original goal of these techniques was to defend against this adversarial attacks. But what the researchers also found is when we prevent the model from being fooled by these adversarial examples, at the same time we make our model more robust. We make the model generalize better because it is less. It's not as delicate. It's not as sharp in its predictions. So one of the techniques that I've used personally in a couple of projects is adversarial weight perturbation. It was designed to do some perturbation during the training. So what happens during the training is we first do the classic backward pass, then we check the gradients, and then we make slight modifications both to the inputs and the weights of the model. And then we run another optimization on the parameters. And by doing this, essentially what happens is we flatten this loss surface. We go for this wider minima, and because of that, the model generalizes better to unseen data. This technique is actually quite powerful. It does require some time investment. The training run can be quite longer, like 2 to 3 times longer. There is a set of additional hyperparameters that you need to tune, such as adversarial learning rate. But the model actually works very well. I'm gonna show you a chart from an NLP competition a couple of months ago, where we used adversarial weight perturbation. And what you can see, let me first show you the train loss. So what you can see here, the blue line is the train loss without AWP. And then the orange line is when adding adversarial weight perturbation. So first, the loss is generally higher. And the reason is we're adding these adversarial examples, which are harder for the model. And then we train this model for longer, and then the loss keeps going down. The loss would still keep going down for for the blue line as well, but it would start overfitting. So and this can be seen in this actually in the validation loss. So again, initially the validation loss is quite higher, but then we train this model for longer. It's not overfitting. The loss keeps going down, and actually the model works much better than without AWP. So very powerful technique. It can give your model better performance. It can make it more robust. It does require some tuning and some additional effort to make it work well. Okay, let me go back to the slides and check if there are any questions. Okay, if no questions, then moving to the last set of techniques, and I'm gonna change a bit the focus now. So what we covered in the past slides were more of like machine learning techniques specific to NLP or specific to deep learning, and now I'm gonna talk more about debugging and good engineering practices. And this is something like I give it the title like, was it my fault? And the reason I put this title is I've experimented with quite a lot of different machine learning techniques, especially on Kaggle. In machine learning competitions, you want to try a lot of like state-of-the-art methods that have been published, and to try to improve your model. And some of these techniques work, like this adversarial weight perturbation, some of these augmentations that I've showed, but some of the techniques do not work. And then what happens is like you do not know, do these techniques not work because, you know, maybe they are not fit for this data set, or maybe like they never worked and it like they were just they are actually not as good as some people claim. Or maybe I made an implementation mistake. Maybe the fault is my implementation. Maybe I used this technique in a wrong way, or I implemented it incorrectly. And how do we debug this? How do we improve our models and our engineering game? And this is something that is obviously hard. Like it's difficult to find these bugs. It's difficult to fix them, and it does require some art and skill and time and effort. But the things that help me personally is following this sequence of activities. So the first thing is starting with a simple baseline, and I often I always try to remind myself to do this. Whenever you have a problem where there is a standard solution like implemented in one of the popular libraries like sentence transformers or transformers, or like Hugging Face or Spacey, like starting with a good default solution and checking its performance is usually quite good, because then you can gradually add complexity and step by step kind of like when you add it step by step, like it becomes manageable. So start with a simple baseline. And then what I do recommend doing is obviously adding weights and biases for tracking, for experiment management. And but I also want to be specific here. It's not like, you know, use weights and biases because it's good. It's like it gives you some special benefits that can be helpful when debugging your models and trying to improve the results of the experiments. Integrating weights and biases sometimes that may require some effort, but usually it's quite easy. And the first step that you can do that essentially costs you nothing is like using weights and biases to save code. In the past, I would usually save code in GitHub. I still do this, but the problem with GitHub and machine learning experiments, it's hard to keep track between like which version of the code resulted in what type of performance of your model. So what I usually do now, whenever I start training a model, is I add one line of code, which is 1 dB in it. And just adding this line of code, like import 1db and 1db init, this gives me already one big benefit, which is code saving. And that's a feature that needs to be turned on. Like we don't turn this on automatically because some people might prefer to opt out. So you need to actually go into the settings and turn on code saving. But once you have it saved, then what happens is like, even if you train your model in a Jupyter notebook, even if you run your cells in arbitrary order, like we will save the whole session history, and you can see in which order the different cells here were executed. And essentially, like you can reproduce this experiment. You can see at the result here. You can see at the different metrics that you tracked in this experiment, and you should be able to go back and reproduce it. And that's something that personally helped me many times find bugs. Like I would go back to this session history, like check how I executed the code, what was the order, and then I would see, hey, like this is where I had a bug. Like I feel like I think like in a recent project, like I trained probably like around 30 to 40 experiments with a bug in my code, and I was able to go back and the bug was a bit nuanced. Like it's still like my model still trained. It did not train optimally, but I was able to then go back and check like in the code on which experiments like the bug was still there, and that helped me like go back and rerun the best experiments like with removing these bugs, and it did help me quickly recover from that issue. So that's one feature I would recommend using. Turn on code saving and add 1db init, and then you have this code execution linked to your model results. The next thing is save configs and then log everything. And again, this is something that I think I'm gonna use. Maybe I can use this example. This is actually from a computer vision project, but this is like equally applicable to NLP or any other machine learning problem. The way to save like config is your set of hyperparameters that you use for training, and you just save it by adding a dictionary with the config values to your 1db init. And then once you have this config saved, and once you also keep logging the different metrics that are relevant for you, then what you can do is you can go to, let me go back to my project overview page. I can go into this like table view, and then, you know, maybe let's say I'm interested in recall again. So I'm gonna pin my recall score, and then I want to compare, let's say, different architectures and see how they do in terms of recall. So I'm gonna pick this architecture, which is again a value that I put into the config. I can maybe group by different architectures, and I can then maybe sort it in terms of recall. And here I can see that, you know, again, this is computer vision. ResNet 18 seems to have the best recall compared to some modern architecture backbones. So saving your configs and logging data to weights and biases, like personally for me, this gives me like a massive productivity boost. I often start working on a project alone, and then I often like have other people join a team and then start collaborating. And I would get questions like, you know, have you tested this or have you tested that? Like, what was the result? And in the past, like I needed to go back to my notes and try to remember what I've done and write this up. But what I do right now is like I just, you know, give people a link to this workspace, and they can just figure things out on their own. Like whatever is interesting for them, it should be in the configs, it should be in the logs. So it's quite easy to pick this up and find it. And the final thing, which I think like gives you superpowers, is visualizing inputs and predictions. And this is probably the part that requires maybe a bit more engineering and implementation. because often if you work on a specific problem, then trying to visualize it may not be trivial, and you may need to invest some time to figure out like what visuals help you there. But if you figure this out and implement it, then using these visualizations for predictions, this can give you insights to improve your models even further. So I'm going to share 2 examples here. One is from a span detection and classification. These are medical. This is in the medical education domain. These texts are written by aspiring doctors, so medical students that need to diagnose patients and write up their notes with the diagnosis. And what people checking this, like this is an exam for a medical doctor. Like you need to be able to talk to a patient and figure out the right diagnosis. And the patients are actors, so they know what they need to say. So there is a set of correct answers. And what we do here is we check this write-up from the student that is going through the examination, and we try to pick up the right elements of the diagnosis, which is a set of spans and then classifications for the span. So in this case, I'm trying to pick up that the patient is 26-year-old, the fact that it's a female, then the duration of certain symptoms, and then what type of symptoms were experienced. So here, like this is like episodes of heart racing, and this is like a span detection and span classification problem. And by doing this visualization here, and logging this visualization for my predictions, I can see like where my model is making mistakes and how the model is getting better over the training. So figuring out the right visuals and implementing this can help you a lot. Like in this case, like I can see maybe the model is making some errors here, maybe on the boundaries of some tokens. Actually, I think in this project, by doing this visualization, I realized that my tokenization was wrong, and I picked up like just elements of some tokens here. So doing this visualization can actually give you insights to improve your modeling. Another example, and again, this is a recent one from information retrieval. What I'm trying to do here is why has it expired? Maybe let me refresh it. So what I'm trying to do here is I'm given this set of information around the topic. So I have a title, I have a description which might be missing, and then I have a set of attributes for a given topic. And I need to retrieve content items that match this topic. And for each content items, I have again a bunch of attributes. And what I did is I have like what I developed is this bucket chart, which shows me all of the content items that I retrieved. And the ones, actually all of the items that I retrieved are the circles here. The ones that are correct are marked in green. And then I have these triangles, which I did not retrieve. So this is something that my model should pick up, but it didn't. And I can figure out, maybe from this visualization, I can figure out like what I'm missing. You know, maybe my model has too short of a sequence length, and it's not picking up the right attributes. Maybe I need to have a more powerful backbone to pick up some semantic nuances of this data set. So figuring out the right way of visualizing your data set and your predictions, and using it to get insights to improve the modeling, I feel like a very powerful skill, and can help you develop much better models. Okay, let me do the final pause around questions, and then I'm gonna go back and do a recap of the presentation. Okay, so to continue, I was supposed to give 10 techniques in the title of this presentation. So I figured, okay, let me just try to list 10 techniques. I feel like generally the big trends that I find are important is looking at the data and seeing how you might expand your data set and get more data and benefit from it. choosing and tuning, choosing the right architecture and figuring out how to get a good set of hyperparameters, generalizing to get to this white low place on the surface of your loss function, and then applying some of this good engineering practices to train better models. Like this is something that has worked for me, and I hope you can also find value in some of these techniques. If you want to have a more of a deep dive into weights and biases, so the last part of my presentation, I do recommend checking out www.1db.courses. We recently launched a free MLOps model development course, and we cover some of the things that I showed you from weights and biases. So that's one thing I would recommend. And another recommendation, and this is specific, like since we're in the Munich NLP group, there is actually a Munich Data Geeks meetup with weights and biases that's happening on the last day of February. So I do recommend those of you that are in Munich to check it out. Potentially, you'll be able to meet some of our weights and biases employees in Germany that are quite good machine learning engineers, and you get a chance to chat with them. And the final thing, like as promised, we have some weights and biases swag, and what I would recommend you do to get a chance to win some swag is join weights and biases Discord at 1db.me/discord, and then share your own tips for training better machine learning models faster. Like you've heard from me, like what works for me. There is a bunch of great machine learning engineers on this call, I believe. So if you can share your own tips, things that work for you, I think we can maybe crowdsource some good set of best practices. So yeah, we'll pick up to 3 authors of these tips and send you a little gift from weights and biases. So I appreciate if you can share your knowledge there. If you want to share it here in this meeting, I feel like we still have a couple of minutes. So, I would, this is the last slide that I have. Happy to answer any questions or hear your own advice, especially if it's orthogonal to what I shared. Like if you feel like you would do some of these things differently, I'm very much open to that conversation as well.
Thank you so much. This was very exciting, very interesting. While we're waiting for people to maybe ask some questions in the chat, I have a question. I see that your Polish version of BERT was trained on 4 corpora, right? So the open subtitles, the paracrow, and the parliamentary corpus, and the Polish Wikipedia.
Yeah.
How did you find, what challenges did you encounter while training it, and what problems did this corpora have?
Yeah, that's a very good question. So I remember like when I trained BERT, like I think the biggest amount of effort was actually figuring out like where to get data from and curating that data. Like that was probably 80% of that project was on the data side. And that was a couple of years ago, so we didn't yet have some of the data set libraries that we have today. And yeah, I just tried to find whatever is available, like whatever large corpora of text there are. Like this seemed to be the biggest corpora, and yeah, I just took whatever is available and is kind of reasonable. What you can do, what I did later actually, so it changed. I feel for the better. Like when we trained a Polish version of GPT-2, and that was I think maybe like 1 or 2 years ago. Like we were already able to benefit from Hugging Face data sets, and there is this large common crawl data set which is also curated to some extent and is available in multiple languages. So like the data set part is definitely much easier now than it was a couple of years ago. But again, this goes back to the data is key point of my presentation. Like even for this pre-training and for fine-tuning, I feel like choosing the right data set is probably the most important decision. I feel, and this is my personal opinion, but I feel like the success of ChatGPT is also it's not so much driven by the architecture choices or the technology choices. It's much more driven at the amount and the effort they put into collecting high quality data for training this model. So yeah, I believe data is key indeed.
We do have a question in chat. Do you think that size architecture of transformers are important for Polish language?
That's a great question. Yeah, I feel architecture is kind of like probably like a transformer is all you need right now. So I feel like architecture is probably not as like it is very important, but it seems like people converged more or less on the transformer. I do feel like the data set size is probably the most important thing. And scaling a model, like scaling the model size without having without having correspondingly large data set may not be that beneficial. So I feel like the biggest opportunity we have is on the size of the data set, and probably as a next step on the size of the model. I do feel like the multi language models are also quite good. So potentially the solution is not to train a Polish or a German or an English model. Potentially the solution is to train a multilingual model, and then we can benefit from data in multiple languages, and we can also scale this model to a bigger size.
So another question from Lucas is, what do you think was the impact on the ChatGPT performance using the fine-tuning approach, reinforcement learning plus cost function ranking?
Yeah, good question. I feel like this had a massive impact, and we can test this out ourselves, because like what OpenAI makes available is the GPT-3 models and the Instruct GPT and then ChatGPT. And I think the key difference of ChatGPT versus like the GPT is this reinforcement learning with human feedback. And I personally feel like it makes a massive difference. It's also, yeah. So I feel like this reinforcement learning with human feedback, like this fine tuning, is fundamental to the success of ChatGPT. That's my personal opinion.
Piotr is asking what kind of resources one needs, for example, computer power, what are needed to train ChatGPT only on Polish.
That's a great question. I don't know if I have enough details about ChatGPT. I have not chatted with OpenAI, so I have only speculation on my side. But what we do have available as open source is like maybe the eLuther AI models, like GPT-J, GPT Neox. Like we have let's say we have the open source counterparts of GPT-3, and I think like we should be able to fine tune them on a given language, like Polish or German or Turkish or whatever. And I feel like the biggest effort there would be probably like compute is one, but I think like even bigger effort is actually collecting like doing the data labeling and collecting this fine-tuning data set and providing feedback to the model. I feel like this is probably like a big element of the investment.
Do you think that maybe ChatGPT, or do you think how much time do you think it's going to take for OpenAI to close ChatGPT and make it unavailable after they have collected all their data?
I'm like that's not a question of machine learning engineer, I believe. Yeah, I feel like I'm an MLE, so I like to think about the technical aspects. Like that's a business decision. Like it's available. I appreciate that. I think it's actually a good decision to make it available very broadly, because people can experience it, and and also like get used to the fact that these machine learning models are quite powerful right now.
this is also quite a subjective question, but in your opinion, I mean, right now, all we hear about is transformers and attention and so on, and this is what is mostly used in the industry. Do you personally have some kind of a legacy method that you still use that is pre-transformer that you appreciate, or maybe you can just share about it?
Good question. Yeah, I feel like the method very much depends on the type of problem. So I would actually like quite often use random forest for different problems. The thing about NLP is whenever you actually need to understand language to solve a task, like then like it's very hard to be transformers, because it's like some of these older architectures, like they don't have any understanding, like they only get the statistical signal, like word frequencies and so on. So yeah, I feel like but there's a bunch of tasks which do not require understanding, and then like these traditional techniques actually work quite well. I feel it's like these are all tools, and it's good to have like a good knowledge of how to use these tools.
Thank you for the answer. Atarva is saying in the chat, hi Darek, great presentation. Just a quick question. How is the table and the scatter plot inserted side by side into a media panel? In the LECR chart you showed on weights and biases, like which component of weights and biases was used?
Yeah, great question. And the fun thing is I actually use ChatGPT for that. So the way I use ChatGPT is like this combination of a scatter plot and like the table. It's an HTML element. So in weights and biases, like you can upload HTML as a media file and store it as a prediction or as a visualization in the dashboard. So this is HTML, and because I'm not a front-end developer, like I ask some help from ChatGPT on the HTML programming side. So yeah, so it's HTML.
Piotr is asking, did you try state space models?
The answer is no, but I'd be interested to learn more about this. I need to check it out.
Okay, so if there are no more questions in chat, I would just like to ask one last thing. Also, this is a subjective question, but do you have any personal interest or maybe an interesting paper that you read recently that you would like to share? Just something that maybe excites you personally, just something that you find interesting.
Yeah, great question. I feel like I'm not sure if I have a specific paper, but personally I've been super excited about like using machine learning and especially large language models for drug discovery, and doing things like protein language models, understanding, like being able to generate new proteins, being able to predict properties of proteins based on language models and the data that we have. So I feel like this is a very interesting world where a person that developed some NLP skills is able now to go into like biological and biomedical domain and use those skills from NLP to solve like a totally different problems. So that's something that I find exciting. Like I don't feel like I maybe I have enough of expertise in this new domain, but yeah, I try to educate myself on that.
Thank you. Sounds very interesting. And because we're quite on time, I would also ask the question that Piotr also asked in the chat. He asks about tokenizers for Polish, and if you have any suggestions.
Yeah, good question. So tokenizers, like especially with transformers, like tokenizers are often bound to the model, because whenever you train a model, like you need to first set on a tokenizer, and there are different types of tokenizers, like sentence piece, word piece. I don't think I have any preference there. I think like anything like any of this word piece, sentence piece tokenizers, like they typically work quite well across a set of different languages. So it should also work for Polish or any other language.
Okay, thank you. Thank you so much for joining us. This was a very interesting discussion, very interesting demonstration also. Thank you for showing us this weights and biases demo and your personal experience. And yes, as we said, we're going to have a live event at in Munich on the 16th of February, and we will also link the event that Darek mentioned that's going to be also in Munich in the end of February. So yeah, thank you so much for joining. This was very interesting. Thank you.
Thanks, everyone. Have a great evening. Bye-bye.
Thank you.